Hello there, and welcome to the second part of my modular dungeon tutorial series. In this part, we'll have a look at large inner corners. Make sure to watch all the parts of this modular dungeon tutorial series in the right order, as I've explained some steps in the first parts, which I won't repeat in detail in the later parts. As before, you're going to need Blender, GIMP, and XNormal. Since the process of creating these assets won't change much from the basic wall to this corner, we will lie the focus mostly on creating the low poly model, since this is the only part that really changes. Alright, so we left off with this basic wall, and we're going to use that now to adjust our corner to the right scales and the right geometry that we've used on the wall as well, so they perfectly interconnect with each other. As always, start with a plane, activate the snap tool, and move the origin to one of the corners of this plane. Then just extrude out the edge, so that you get this basic corner shape. Now you can create these 9 loop cuts that we've also created on the basic wall, so this way we create the basic rows for our bricks. Now since this is a corner, if we would extrude these floor parts now, they would overlap. So we need to add additional loop cuts so that we can kind of create this intersection. Now you want to know the exact length of this extrusion at the bottom. Since the loop cuts will make it able to create a square, they need to have the same distance from the corner of the wall as the extrusion of this floor part. Since the extrusion of this floor part is 4 units long, we want to move these edge loops exactly 4 units away from the corner. Then I adjusted the placement of this basic shape to the placement of the original wall. Since we've moved the basic wall in a bit, we need to do so for both sides of this corner. Now it's just a matter of recreating the exact same look as the wall had. So in the wall part, I've added this additional loop cut at the top row to create these stones at the top, and I'll do the exact same on this corner model, and then move in the vertices so that they also have this slanted shape. Now we can extrude out these floor parts. So after extruding out both, you will see that they perfectly meet at this square point. Now you should keep in mind that since we've extruded out both, this point is not yet connected, since both have a vertice at this edge, so you need to make sure that this vertice gets merged either by merging them together or searching for remove doubles. So you could fill in this basic face so that you would just have this look of the two walls meeting in this corner. But to increase the dungeony style of this asset, you might want to create a pillar in this corner that suits to the end stones at the top. Therefore, I'll just move out these vertices in the corner to this point that we've created by extruding, and then we'll have this extruded pillar in there. Now since the pillar is supposed to bear the weight of the ceiling, and is usually not just a decorative element, you want to make sure that this top part also fits to the ceiling level and suits this blocky style at the top. Now you can decide whether you want to stick with this straight pillar, or add another slanted edge at the top so that you can create another end stone on top of the pillar as well. In this case I decided to slant the edges so I have some more interesting geometry in this low poly model, especially since we use very low poly models with not much edge definition. We want to make sure that there's something for the shadows to show, or that's interesting to look at. Now to finish off this top part, I'll just extrude out single vertices, then select 2 of them, hit F to fill in the edge, and then select all 4 and hit F to fill in the face. Now lastly, I finished off this bottom part and raised it to the same level that the original wall was at, and made sure that I didn't create any back faces that wouldn't be shown but would increase the poly count with no reason. So make sure to check for back faces to delete them, and after you're done, make sure to search for remove doubles again to remove any double vertices that we've created by accident or since we needed them to interconnect two pieces. Now before you move on to the high poly part, you should make sure that this model perfectly fits into the basic wall from both sides. Now since this is a low poly model, you could also search for parts where you are able to reduce the poly count. In this case I was able to merge these vertices at the top, which created two triangles, but that's no problem since we are finished with the model. Make sure to only reduce the poly count at the end of the low poly modeling stage. For some methods on reducing the poly count, you can check my overview video on poly count reduction. Now again I've searched for remove doubles to just make sure that there are no double vertices, as this could create artifacts in our bake later. So now we're ready to unwrap this low poly model. As always, I've set up this basic color grid, so once I hit unwrap, I see if there's any stretching. Now the same thing as in the first part applies. A good rule of thumb is to mark edge seams wherever there are harsh angles. Now in this case, I chose all the 90-degree edges, as well as this slanted edge at the top. Since the faces of those two sides point into different directions, they else might create some errors in the baking. Now it's time to adjust the UV unwrap. This is the same principle that I've used in the first part. I made sure that I know which UV islands represent which geometry in the world, so it's easier for me to find them if I need to paint on them or search for little baking artifacts that I want to fix in Gym. So I always know if I see any texturing issue, where it belongs to in the UV map. Also, as always, make sure that there's enough space between the islands for the X-normal edge padding to work. Another tip I'd like to give you is that I usually try to rotate the faces so that they are at the right orientation or the same orientation as in the 3D model, so that if you need to edit something in GIMP or Photoshop or whatever you use, you already have the right orientation and don't need to kind of paint upside down. Now this doesn't work for all the parts, since in this case, for example, I need to rotate some of them to kind of use the space better, but usually you want to make sure that they are not flipped or mirrored. Now here you can already see one of the issues with this big corner part. In comparison with the basic wall, this model has way more geometry for the same texture space, so the single UV islands are smaller and thus will represent a lower resolution. Now at the points where this corner interconnects with the basic wall, you will see this difference in resolution. Since increasing the size of these islands is no possibility as we already covered most of this space, the only option would be to increase the image size to increase the resolution. Usually this is not an option for game assets. To fix this instead, you should create smaller corner parts, which I will show you in a different part of this tutorial series. In that case, you will just create the pillar of the corner with some of these interconnecting edges, and then add another half wall model to interconnect between the basic wall and this corner part. This way you have unique textures for this half wall and this corner part, and thus you will have more resolution on both of them. Alright, so after we finished unwrapping, we can already start to create our high poly model. So if you followed some of my other videos, you will know that I'm quite lazy. In this case, we won't call this laziness, but recycling. Now what do we recycle? Since we've already sculpted out stone bricks for the basic wall, we can reuse those. For that, I've just imported this high poly model from the basic wall, went into edit mode, hit P, and separated by loose parts. This way you will regain all the single bricks from this high poly model. Now it's exactly the same method that I've used in the first part. I'll just move around these bricks to fit them into the basic low poly model that we've created. Since this corner part uses some different scales on some edges, you might need to rescale some of those blocks. Just make sure that they fit perfectly into the borders of this low poly model. Now, because of the unit sizes I've used for this low poly model, there are some spots that I have no fitting brick for. In this case, I've just duplicated one of the normal bricks and rescaled it, but that created some sort of clinched look. You should create new models that fit these spaces and sculpt them. So after you've moved around your bricks from the basic wall to fill in the spaces on this corner part, you're left with this corner pillar. Now the same method as always applies. Create fitting bricks for this corner pillar, then use modifiers to transform them into high-res versions and sculpt on them. In this case I've used pretty big bricks. One reason is my laziness, the other is that you don't want too much detail, as I've already explained in the first part, since else it will draw too much attention. Now we're ready to merge this all again. So select all the bricks, hit Alt-C, mesh from curve to apply all the modifiers. Then lastly select the background plane and hit Ctrl-J to join them and set it to smooth. Also make sure to create a duplicate of this low poly model. Now rename both models and reset the location to the center. Then duplicate the low poly model again and name that duplicate cage. And then, as in the first part, just move out the single faces to create the cage. Just to remind you, you want to make sure that the cage always covers both the low poly and the high poly geometry. So as always, just export these models into OBJ format to import them into XNormal. In XNormal, just drag and drop the high poly model to the high definition mesh tab and the low poly model to the low definition mesh tab. Then right click the low poly model and select cage. Then you can bake out the normal map, the ambient occlusion map and the curvature map. Now I've used the exact same method as in the first part to create the texture, so that both models will look the same. Just to repeat, I've overlaid the ambient occlusion map over our basic rock texture with multiply, then used the clone tool to get rid of any specific detail in that texture. Then I've imported the moss texture and used the information of the curvature map, the red channel, as an alpha mask for this moss texture. I've used the curves filter to adjust the amount of moss that is seen. Lastly, I've merged all of this, desaturated it and used the levels filter to create my specular map. So the advantage of this large corner piece is that we only need one single texture for all of this space. As I've said, the main disadvantage is that the resolution on the single bricks is reduced. Now you need to decide whether you want to show these models from close up, so you should create smaller models to increase the resolution on each texture, or you want to use this from top down, and simple differences in the resolution of these models won't matter that much. Alright, so that's it for the second part. If you follow both parts, you should be able to create any sort of geometry you want with these two models, since the steps are always the same. In the next part, I'll show you how to create the smaller version of this corner piece, as well as the half wall, and then we'll move on to some more decorative pieces such as pillars in the walls and similar things like that. And lastly, we'll move on to decorative environment pieces. If you have any suggestions for these, such as bones or a treasure or torches, just leave me a comment. Thanks for watching.